Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, we are still building a MachO reader. And yeah, we want to implement this function probably, or maybe we need a different strategy. I was thinking that maybe it would make more sense to implement a new vector here, put a vector that has pointers to all base classes in a meaningful order, so that we don't need to like look it up with a function that loops through things and finds it, but something where we have it prepared already, right? Maybe we could do that. Yeah. Maybe. Yeah. Yeah. Then we could also simplify this function here. Yeah. So so we would need to build it after when would be the right time? Type info. I think in type info we built the base classes here. Yeah. So parse p-extend, generate classes from functions. So we would probably build it here. Build base class links. Yeah. We have this function here, and we would create a new one. And then, yeah, so basically in here we would then generate for all for all classes, we would have std vector base class pointer base class all base classes. All base classes ordered by all base classes ordered by base class offset and ordered by base class offset and hierarchy. I don't know how to describe it. All base classes. Ordered by class. Ordered by base class offset and how do we describe it? Like how far it's down the hierarchy. Ordered by base class offset and maybe call it base class pointers PTRs. All base classes ordered by base class, ordered by offset, base offset, and depth. Base class by base offset and depth. Well, before we worry about documentation, let's worry about implementation first. Yeah, that's a real problem. I mean, we have something here, then we have this here. Yeah. How did I implement this? Base class count. Base class without vtable. Can we multiple base class and offset 0? Get base class depth. Okay. So we will loop through all classes and then Yeah. Build base class links. I mean, we have our class. So all contained, all base classes in hierarchy. So we probably need a function void collect base classes, collect base classes at offset 0. Okay, std vector base class pointer, base class ptrs. Collect base classes class type and class type dot this. And then when this is done, then we'll have another function, collect base classes at collect base classes at offset 0. Yeah, before we worry about this, let's see. So here we would class type dot base classes. So we would have four base classes, yeah. And then I wonder if before we call the first, before we call the first before we work on the first base class, we already call, by the way, this needs to be a member class. By the way, let's move it down here. Let's take it. And then we call m classes base class dot class index class base class type class base class ptrs. Okay, and then only afterwards we then do base class dot base class pointers dot push back the pointer to this base class. So I wonder what this will give us. Let's test that. Let's make it int a0, so I can put a breakpoint here. So I test. Okay, so if we go in here, we have base classes, one base class type, memory pool object. And so we step in there. It doesn't have a base class, there's nothing to do here. And then we push back this guy in there. Okay. Okay. Okay, this looks fair. Let's put a breakpoint here and let's see what kind of results we get. Let's put it here. Okay, so here we have, oh, we don't see the name here. It would be nice to see the name. Yeah, okay, but we can see the base offset. Oh, it's a starter. Yeah. Well, what we can do is, it's okay for now. I think we can work with it. So here we have 0. Okay. 2. Offset 0 and 0. Offset 0 and 0. So m classes, what do we have? 0 and 1. 0. 0 and 1. Actually, let's just go to update module. If class type dot m name equals update module. Okay, let's check one of the more complicated ones. Okay, update module. Let's go in here. We have a base class. Okay. Okay. So we step in here. Object module. We step another module. We step another memory pool object. We step another, and this one is 0. Okay. So now we push back the first base class, which is memory pool object, which is at offset 0. Okay. then snapshot. But that is already at offset 4. Yeah, but it's one of the outer leaves. Yeah. Yeah. But I think that is fine. That is fine. Yeah, I think that is okay. Well, but then the ordering is not by base offset. Yeah. Module offset 0. Object module. Okay, so what do we have? Module. We have now offset 4, 0, 4, 0, 0, 10, 0, 14. I think it's not too shabby. Yeah. Base offset 14. So the order, yeah. Mm-hmm. Mm-hmm. Yeah, I think the order is okay. I think that's reasonable. So I would say we say here the comment all base classes in hierarchy ordered ordered from leaf to root. Or let's say leaves ordered from leaves to roots. I think there's leaves. Plural of leaves. Okay. Okay. Then now with this equipped, that makes a lot of things easier. Then we can collect base classes. Collect base classes recursive. Okay, that means we can delete all this. And we don't need this. And then we can, I think that means we don't need this here anymore. These two we don't need anymore. Actually, hold on. This one returns a base class that is nearest, actually. At 0. Yeah. Get base class. Get base class. Oh. Maybe we do a change of base class. How does that work? Why? I mean, here, with the new function we just added, we don't do any changes to base class offsets. Why did this work? I'm a bit surprised by this here. Oops. Let's put a breakpoint here. Hmm. 28. 28 minus 0. Four minus 0. 4, 0. Let's put a breakpoint when this is not condition. This is not 0. Okay, so this is now 4. Base offset 4. Then what? 4. So base offset 10. 4. let's say conditions this and base class type dot m classes dot sci. I don't know if that's possible. Probably not. No, it's not possible. Oh. Base classes. Oh, that is possible. 20, 28, 20. Oh, that's possible. Okay. Okay, let's go in there. Base offset 8. Okay, how about we create a new one? This and base class results is not null pointer. Will this ever hit? It does. Offset 0c gives persist class. What? Okay, let's double check that. If that is true. Copy value. Copy value. Persist class is at 8. Offset 8. Huh? Offset C. vtable. Render object class. On post load, get factory save load. And this has given us now persist class. It does have a vtable. Persist on post load, get factory save load. On post load, get factory save load. Okay, it does match. Okay. If we look at class type, base class pointers, would that mean that we have to adjust those offsets? But then how we do that? So the offsets are different. Right, so we would need to adjust, I think. Yeah. Base class. How big is this thing? It's just 8 bytes. Okay, it's as big as a pointer, basically. How about we make a copy of this? Basically, the so we could call this direct base classes and this all base classes. And then in all base classes, we populate this, but we don't use pointers. We use also base class in place as a data member. But we adjust the base offset towards this class. Yeah, so that it can also be looked up with the vtable, the secondary vtable offsets. They cannot look up here directly. These ones here, the pointers offsets in here from the original ones, because the base offset there relates to the class that this base class is contained in. Yeah, so these are different. They need to be adjusted. Yeah, they need to be adjusted. About these rocks. Okay, then how? Direct base class inheritance. Direct base classes. Okay, so we would rename this to all base classes, and we would make it not a pointer. And then base classes. There we go. Yeah, and then base classes, base classes, base class. Okay, and then we would need to adjust the pointer, the offset. Offsets. Let me see. Offset. How do we do it here? Base offset minus base offset. Minus base class base offset. What is this base offset? Okay, before we continue here, we should be able to create a we need like a check. Build base class links. We can have a let's create a void verify base class links. Make it return a bool. Yeah. And we do assert verify base class links. And then we create a new function. And there we say return true at the end. And we need to give it a class. Hold on. Class const class, and for const vtable m class type dot m vtables, and then vtable dot offset, and then basically for const base class m base classes base classes bool offset found false if base class dot base offset equals vtable offset, then if offset found true, break. Let's say int offset verify base class links. Let's do offset match count 0, return offset match count size t, offset match count equals vtable dot size plus plus okay, vtable dot vtable vtables dot size. Okay. Assert. Why is this? Right, class type. There we go. Okay, so this should match then. My suspicion is that this assert will hit with this right now. Let's see. There we go. Yeah. Okay, so what do we have here? Class type. Vtables. Oh. Offset match count. Base class is 0. Offset 0. Oh, okay. Well, in that case, then we need offset match count base classes. Let's try that. I still think that will hit, of course. Retry. Okay, what do you got? User preferences. Okay. User preferences. We have vtable, offset that, base class. Aha, offset 4. Yeah. I think we only should check the secondary vtables. So if class dot size is smaller than 2, return true. For index t, index 0, index, let's do index t size count count smaller than 2, smaller count index plus index so index t vtable index vtable count offset match count vtable count, and so at the end we expect that this matches this. There we go. Okay, how about we try that? Let's say skipping primary vtable because there can be a base class, because class can have base class without vtable at offset larger than 0. Vtable count. Vtable index 1. How about we say if say larger to vtable index -1. We don't actually need this check here. Well, actually, never mind, we do. I think we can simplify it to this check. Larger than 0. Okay, let's see when that is hitting. Okay, body module. What do we have here? All base classes, 7. Okay. We have 10, B0, no. 4, 10, 14. 4, 10, 14. 4, 10, 14. 4, 10, 14. 4, 10, 14. Isn't that a match? 4, 10, 14. Huh? Oh. Okay. Huh? No, I don't get it. Why is this asserting? That shouldn't have asserted, no? Oh boy. Class type. What is wrong now, huh? 7. 7, 4. 4, 10, 14. 4, 10, 14. That's correct. Why is it asserting? Oh boy. Four, 10, 14. Seems to be fine. I don't know why this is hitting. Table index 1, 1. Oh, I see. This should have been all base classes. There we go. Let's try this again. I can't believe how many errors we have in one function. How hard can it be, huh? 1,000 errors. My gosh. Okay, next error. What's the next error? Let's see. Terrain tracks. All base classes. And... okay. For C14. Aha. For C14. And here we have 8, 10, 4. 8, 10, 4, 8, 10. Entry 7A. So what belongs to what then? So I guess the 4 belongs to the 4, but C belongs to 8 and 14 belongs to 10. That's my guess. Okay, and so we need to make a correction here somehow. So we need to adjust the same as we do here. Offset, base offset. What is this base offset? Base offset. Base offset. Let me see. Base offset, base minus base class base offset is deducted from this one. Yeah. How do we implement that? I guess we would need to pass like here another argument where we say base offset adjustment or something like that. Yeah. Let's see. So collect. So we would need this base offset adjustment, and we start with 0, right? And then we would class type. By the way, I think this one, I think class type can be const. Yeah. Okay. Const. Okay. Base class. And then here we say So we have 4, C, and 14. 4, C, and 14. So we need to add this. So we basically need to say base offset adjustments plus equal base class type dot base class dot m offset, base offset, right? And then we pass this in here. And we actually make a copy of this. Hold on. Base class dot base class copy base class, and then we do base class copy dot base offset is plus equal base offset adjustment. Base offset adjustment plus equal base class dot m offset. And then we give the base class copy here and this here. Is this correct? Maybe. Maybe. I'm not 100% sure. But this will tell us. If this passes without errors, then it should be correct. Hopefully. No, still fails. Listener object. 0 and 50. Okay, then that's not quite right here. What's the mistake? I think 2.8, yeah. 50 is twice 2.8, so we just add this on top. Yeah. What does that mean? How do we fix that? Oh boy. I think we have to give it just here. the base offset. Or basically we move this here. We just pass it here, like this. That might be the proper way. Yeah, and then we could move this here. Oh, it's really quite finicky, isn't it? My expectation is that the assert will still hit, because of course we didn't get it quite right. Okay. Okay, we had a different assert. Okay, interesting. Okay. So that means oh boy. So this one is actually passed without errors. Okay. So that means this is correct now. Okay. That means we should also be able to simplify this function now. This one. So basically the only problem is if base offset is 0, yeah. std r finds, Jesus Christ, r finds, huh? Is it find if? R find if? std r finds. Isn't that a thing? It is. Oh, that's in string. Finds algorithm. Isn't there an r finds? R finds. We can give the reverse iterator. So std find include algorithm std find all base classes dot r begin all base classes dot r end get base class. I think we can also make it get base class const. How about we make a new copy of it? Const this offset. Copy. Const. Search from back because the first base class at offset 0 is at the back. I think. Or let's say the top base class at offset 0 is at the back. Which is basically what this one also returns. As defined. So this one const base class return base class dot base offset equals base offset. There we go. And we return const. We remove this. Somehow it's complaining about something. Ah, right. std. Iterator it const iterator cr begin cr ends. What is the problem? Const reverse iterator. What? Const reverse iterator. Do I have to write reverse iterator? Really? That's unexpected. If it is not this CR and ID IT return IT return null pointer. Oof. No, I don't like this way this is written. How about we do a for IT begin and IT is not and plus plus IT if IT base offset equals base offset return IT else return null pointer. I think that's much nicer to look at than this abomination here. Yeah, let's remove it. There we go. Good. Okay, so this should now give us, it's still failing. What's the problem? Declaration is incompatible. Why? What's the problem? Ah, const. There we go. So this should now give the same results. Get base class here. There we go. Const. Let's put a breakpoint here. Okay, so the verification is a success. That's good. I like that. Okay, so this one offset 0. And this should now return the first base class, which class type, let me say base class, class index 1. Class index 1 base class. Yeah, I mean there's only one. Let's try to get something more complicated. Class type science info overridable. Body module offset 0. So this one has plenty base classes. Yeah, so the first base class is class index C. And here's the last one, C. So this should be C. Yeah, class index C. Okay, good. Yeah. So this is at 0, 0, 0. 4. In which case will this return this? Let me see. That should never hit, actually, this continue, no? Or should it? I wonder, like, in what scenario does it hit this? Offset 0? Oh, right. If it has a base class, right. Let's see some other samples. 0. Yeah, let's go to watch classes, class type, base class, all base classes. Okay. Okay. Texture load class, texture load. This one also has base offset 4. Okay. Yeah. And we have this assert. Yeah. Okay. Good. Yeah, we will get to this next time. Yeah. Okay. Okay, good. But it looks like what we have done here works. And that means we no longer need these functions here. Right? Because we now have it all in here. And here we can always look it up easily. All base classes. The offsets are normalized to match the vtables here. And yeah. Ordered from leaves to roots. With offsets adjusted. With offsets adjusted. All base classes in hierarchy, ordered from leaves to roots, with offsets adjusted. Now that formatting is crap. All base classes in hierarchy ordered with adjusted offsets. Looks like this comment is too big, so let's place it here. Yeah. Okay, I think then that means we can pretty much remove all these guys. Yeah. So we remove this. We remove this abomination and this abomination and this one. I think we have gone through a bunch of functions and made multiple. Oh my God! Look at all this commented code. My gosh. all this commented code where I tried to make vtable parse work, and it's all, this will all be thrown away. Oh my gosh. And it's even more in here. All this code. I try to make it work, but we're getting there. We're getting there. Yeah. Okay, where are we? Okay, so basically here we will then replace this here, and this should be simple. We just need to we just need here we just need to, where is it? Oh, hold on, I made a mistake. Get base class. We removed the wrong. This one should not have been removed. There we go. So we can now use this one here, all base classes. And so base class index it's index refers to class, all base classes, to class, all base classes. Okay, now we can remove this, and then we can this base class base class count index t const equals m class type m all base classes dot size base class index base index smaller than this. Okay, and then we can remove base class, then we do const base class equals m class type dot m all base classes base class index. Okay, there we go. Move that here. Base class index, base class m class index, base class type, blah blah, and then we do this, blah blah blah. Okay, let's see how that works. Okay, so do we still have a breakpoint here? Yeah. So the goal is that we never hit this, right? Now, let's see. Okay. Okay. But we do hit it. Okay. On what? Class, definition class. Definition class. Definition class. Missing base class. Is it? Okay. What else? Definition class, and that's it. Okay. 1. Missing base class index count 1. I don't know if that's a problem, or if there's just something uniquely wrong with that class. So is first step entry. Definition class. All base classes 008. Base classes are base class. Vtables. Okay, which one is it? Oh, it's a pure virtual. Yeah. Yeah, I think that's because we have some pure virtual functions. Yeah, that are not being overridden, not used, and that's why they don't have a name, and that's why this fails as well. Yeah. Yeah. I think there's nothing we can do about this. That's just the way it is then. Okay, but it looks good to me in principle. It seems to work. Yeah. I think this works. Yeah. Yeah. It's a bit expensive, I think, this thing here. Let's see. From here to here. I mean, we don't have a time measurement, but typically just eyeballing it is decent enough. One. Yes. It is expensive in some terms, but I mean for us it's okay. Also we are in debug, so in release it's probably 3 times as fast. Yeah. Good. Then we can remove this. You can remove this. Yeah. Okay. I think we have implemented everything for the vtables. Yeah. Yeah. If we made no mistake, we have all we need from the vtables. Yeah. Yeah. Okay. Then I would say next session, I would take a break now. Next session we will clean up, and submit what we have now. Yeah, it's time to submit. Has been like a week or longer. Yeah. Okay, but we have a lot of information now for vtable. Everything is here. Yeah. Okay, good. Then I will take a break here. I wish you a great day or night. Until next time. Goodbye.